This is part 2 of 6.06, dry cells. Batteries consist of a series of dry or wet cells. The term battery is commonly used to refer to various types of dry cells. However, to be precise, a battery is a series of dry cells connected together or a series of wet cells connected together. So a battery is a series of wet or dry cells connected together. We have the layer of the first metal, layer of the second metal, and then in between that beige color is acid or salt soaked material. Wet cells share some properties with dry cells, but they use liquid as the electrolyte. A wet cell's construction is similar to that of a dry cell. It is a compact joining of half cells, but a wet cell contains a significant amount of water. I always think of like a car battery. If you've ever picked one up, you can hear the liquid inside of it. A car battery consists of a series of wet cells linked together. It is alternating grids of lead filled with spongy lead and lead 4 oxide. The reactions are, first of all, you have an oxidation. So you have your solid lead plus sulfate yields lead sulfide as a solid plus 2 electrons. You have your reduction. You have your lead oxide as a solid plus 4 hydrogen ions, which are aqueous, plus aqueous sulfate plus 2 electrons yields lead sulfate plus 2 waters. Lead sulfate accumulates on the battery terminals and the sulfuric acid concentration decreases over time. All right, so let's look at the difference between dry cells and wet cells. First of all, the half reaction. Dry, close together in the container. Wet, the half reactions are separate, kind of like the pictures with the beakers. The anode is the zinc for both of them. The cathode for the dry cell is the carbon rod, and it's for the wet cell it's metal with low activity. The electrolytes is paste with minimal water versus a wet cell which is liquid with a lot of water. The oxidation reaction occurs at the anode in both. The reduction occurs in the paste for the dry cells, or what we call AA batteries, and for wet cells it occurs at the cathode. The bridge is a cardboard separator, but for wet cells it is a salt bridge. And in our notes, I added to our definition of batteries. It's a series of dry cells connected together or a series of wet cells connected together. And then I just copy pasted this diagram. Various types of dry cells have specific uses. The commonly used alkaline dry cell is also based on the zinc-manganese reaction. An alkaline battery, however, has a paste made up of potassium hydroxide. Other dry cells are available and use different reactions. For example, a nickel-cadmium is in calculators and digital cameras. The oxidation, the cadmium plus 2 hydroxides yields cadmium hydroxide plus 2 electrons. And then, of course, you have to have a reduction. So you have the nickel oxide plus water plus those 2 electrons yields nickel hydroxide plus 2 hydroxide molecules. You have a zinc air cell, so like in hearing aids and pagers. And the oxidation is the zinc plus hydroxide yields zinc hydroxide plus 2 electrons. The reduction is half of the oxygen, which I know I always tell you can't use fractions. You can in a few instances, so we'll just leave it at that. Plus water plus 2 electrons yields 2 hydroxides. You have a nickel metal hydride, or an NiMH, rechargeable batteries in cell phones and laptops. So the oxidation is the metal hydride. Okay, so that's what that MH stands for, metal hydride. Plus hydroxide yields the metal plus water plus an electron. The reduction is NiOOH plus H2O plus an electron yields nickel hydroxide plus the metal, where M is a complex metal alloy involving combinations of various metals such as vanadium, titanium, zirconium, nickel, chromium, cobalt, or iron. Nickel cadmium, nickel metal hydride, and lithium ion dry cells are used to power tools like this cordless drill. Dry cells are compact types of voltaic cells. Dry cells use spontaneous oxidation reduction reactions. Half reactions are combined in a small casing but still separated into half cells. Dry cells consist of a zinc casing, the anode, cardboard separator, electrolyte paste, and carbon graphite rod, the cathode. Electrons flow from the anode to the cathode. This electrical current powers some electrical devices. Oxidation of zinc occurs at the zinc casing anode. Reduction of manganese dioxide occurs within the paste near the positively charged cathode. So dry cell, it has a zinc casing, the anode, oxidation reduction occurs. Dry cell, carbon rod, cathode, it conducts electricity. The dry cell has the electrolyte paste where the reduction reaction actually occurs. And that's it for this one.